Welcome back. We are to the last section in chapter 9. These differential equations are what we call linear equations, and they have to be very, very specific for us to be able to do this little trick that we're about to do. They have to be in this form. So if that lead coefficient is not a 1, we're going to have to divide out whatever that is. And if it's a function of x, we're going to have to keep in mind that we might potentially be dividing by 0 and things like that. And here's the idea behind this. I just want to show you a quick example. Let's say I have a function like this. And I want to take its derivative. Y prime is going to be e to the 3x, x to the third, pardon me, times 3x squared. What we're doing is we're going to capitalize on that function that's right there. And do you see it? If I integrate that, I get the exponent. That brings us to the integrating factor, I of x. And there's that e to the integral of whatever that coefficient of y is. So we're going to get that first, and we're going to multiply through by that. And we're going to turn this into a product rule. You can see it's, y prime and y is not derivative there, and so on. So we can kind of see that as part of that, and we're going to make that part of what we're doing. So let's first start out by finding the integrating factor, and that's going to be e to the p of x. In this case, that is my p of x, and there. And then my q of x is right there, which I don't know right at this moment. E to the integral of 3x squared dx. And you can see that gives us e to the x cubed. And that is going to be our integrating factor. So we are going to multiply this equation through by the integrating factor. So e to the x cubed y prime, I'm writing this as y prime, plus 3x squared e to the x cubed. And you can see that is the derivative of that. And then y equals 6x squared e to the x cubed. So everybody got an e to the x cubed multiplied to it. And once again, what we're doing is we're forcing the product rule. Do you see I have the derivative, the regular function here, e to the x cubed, and then here's its derivative, and regular function and the derivative here. So this actually is the product rule. And we can write it as such. So this is the derivative of e to the x cubed times y. And what I'm going to do is I'm going to integrate both sides. Yeah, so we're going to integrate here. And we're going to integrate the other side as well. This is with respect to x. And we end up with, now, if we integrate the integral of dx, we just get x. So in this case, we're going to get e to the x cubed y. On this side, I'm going to do a substitution. Let u equal x cubed, du equals 3x squared dx, which gives us 1/3, du equals x squared dx. And there's our x squared dx. And so that's going to give us a 1/3, so 6 times 1/3. That becomes e to the u, so this just becomes e to the u, which is x cubed. And don't forget our plus c, which we don't have an initial one, we will with the next couple. So we're going to end up with a plus c here. And what I'm going to do is I'm going to divide through, I'm going to reduce that. I'm going to divide through by the e to the x cubed. Divide by e to the x cubed divided by e to the x cubed, and divide by e to the x cubed. Now, these two obviously go away. That becomes just 2, because that e to the x cubed is gone. Now this becomes plus c e to the negative x cubed, right? It's in the denominator. When you move it up, you get a positive exponent like that. And that is how we do that. Again, we don't have an initial value in this case, so we can't evaluate what c is, but we will have that for these next two examples. All right, so we have two problems to go through. Let's start with the first one. And we have an initial value, right? X equals 1 when y equals 2. And what I'm going to do for that one is I'm going to divide that x squared out. So y prime equals x over x squared is not equals plus x over x squared is going to be 1 over x, y plus equals, I don't know why I'm mixing those up, x squared. So that's a plus and that's an equals. And I'm going to notice that p of x in this case is 1 over x. So my integrating factor is e to the integral of 1 over x dx, or e to the ln absolute value of x, which is just absolute value of x. Now, very nicely, we said it's positive, so we don't need the absolute value. So I'm now going to multiply the original, or this equation through by x. So y prime times x plus x times 1 over x is just 1, so that's just, and x times that is 1 over x. All right, I'm now claiming that this is the product rule. And you can see the derivative of x is 1. And then here's regular y and the derivative of that there. So this just becomes d over x of xy over dx equals 1 over x. Here we are. Now we're going to integrate. So let's come back up here. This gives me xy equals ln. And I can just save x because we know x is positive, plus c. Now, I'm going to use my initial value here. So this x is 1 times 2 equals ln of 1 plus c. And we know that ln of 1 is 0. So it looks like c equals 2 in this case. So we have xy plus ln equals ln of x plus c. And I'm going to divide through by that x. And that c, of course, is the 2 that we just found. We get y equals ln of x plus 2 divided by x. There is our function. Not so bad. Part 2, same initial condition as the previous one. I'm going to divide through by the x squared again to get y prime plus 2 over x times y equals ln of x over x squared. And we're going to get our integrating factor here. And we're going to do a little bit of extra algebra, so I may have to flip the page here to fit that in. So p of x, again, is 2 over x. So our integrating factor is going to be e to the 2 ln of absolute value of x We don't worry about the constant of integration, that gets absorbed later. Now, I want to make it clear this becomes this. Right, remember that trick where you can bring that 2, make it the exponent? So our integrating factor is x squared. Now look what just happened here. If I multiply this through by x squared, I actually get this. So this actually was already in the form that we wanted it in. So we just went full circle. So this becomes d of x squared y equals ln of x dx, integrating both sides. And I'm getting a little low on space, which is okay. I'm gonna do this trick. And I'm actually gonna go off to the side here and remind us how to integrate in ln of x. So the integral of ln of x, let u be ln of x dv is dx. So I'm doing by parts. So this gives us du is 1 over x dx, and v is x. So this becomes uv minus the integral of x times 1 over x, which is that, so it's just dx. So x ln of x minus x. So that was for this here. So I'm going to continue on with that here for a minute. So this gives me x squared y equals x ln of x minus x plus c. And what I'm going to do is I'm going to go through and we're going to apply the, yeah, it's on screen, there we go. When x is 1, y is 2. So this becomes 1 squared times 2 equals 1 times ln of 1, which again goes to 0, minus 1 plus c. So this becomes 2 equals, that's 0, negative 1 plus c. So it looks like he's going to be 3. All right, I'm putting all of that together and dividing through by x squared. My final answer is going to be y equals x ln of x minus x plus 3 all over x squared. And you could break that up and simplify that. It's good enough. Us. All right. That is chapter 9.